Alrighty, so hello Mr. Hardison again. This is a continuation of me and Ivan's project for CEP. The title of the project was Liquid Densities, Testing Liquids. My name is Colin Petrie, partner's name was Ivan Caria, like you know. Period 4 CEP class. Day due was today, January 20th, 2010. Alright, so the purpose of this experiment was to figure out which among 6 liquids was the densest, was the thickest. Sporting ideas was just that, I'm not really sure what those are, but the sporting ideas for the experiment is finding the density of liquids. Our hypothesis was that the Caro corn syrup would be the thickest, next to the oil in second, the soy sauce in third, vinegar fourth, Coke fifth, and the water being the less thickest, the least dense. Alright, our materials were Coke, soy sauce, cooking oil, vinegar, water, and Caro, corn syrup. We also had a beaker, funnel, and triple beam balance. The procedure was weigh each beaker on the scale and record its mass in grams. Make sure you weigh each beaker separately. Add one of the liquids to each of the beakers. Make sure you add only 50 milliliters of each liquid. Weigh the filled beakers and record each new mass. For the liquid, subtract the mass of the beaker itself and record the mass of the liquid. Perform the calculation for density for each by dividing the mass of the liquid in grams by the volume, which is constant 50 milliliters. Record the density as grams per cubic centimeter. Okay, the independent variable was the liquids. The dependent variable was the density of the liquids. Okay, our observations was that the Caro was definitely looked like the thickest and was the slowest going in. The oil also looked pretty thick, and yeah, we pretty much based our observations were pretty close to our hypothesis. The analysis of the data ended up that the Caro was the thickest with 2.466 milliliters or cubic centimeters density. Alright, then next to that we had the soy sauce, which was really surprising, with 2.034. After that we had the vinegar, which was at 1.888. Following that was the water, which is at 1.874. And in last but not least, we had the Coke, which is 1.872. That's about it. For our conclusion, our hypothesis was correct. The Caro was the densest. But from there on, we were wrong. None of the other liquids were in the order that we predicted, such as we had the prediction that the oil was going to come in second, when it ended up coming in almost in like second. Oh no, oil came in last. Yeah, where the oil came in last, which is, we were really surprised at that. For validity errors, I mean, there could have been a couple where, like, pouring the car because it was so thick it could have stuck to the funnel or in the beaker, and could have thickened up the other ones and made those a bit heavier when we're weighing them. Also, the triple beam balance could have been a bit off. What else? We could have lost a little bit of liquid pouring into the funnel. I don't know how that would happen, but it could have been stuck to. It could have stuck to the top of the funnel or something. And yeah, that was like my summary of the project, because our video was a bit long and pushed out.
Today we are doing a project called liquid densities, and my name is Ivan Kara, his name is Colin Petrie, and we're period 4 for CEP,
and I'm doing that.
And the due date was today, and me and Colin are the partners. The purpose of this is to find out which liquid is the densest, and supporting ideas are just that, you know, liquid has all different types of densities, and it's all liquid. So yeah, that's that. And our hypothesis is that the Caro will be the densest because because it's the thickest, and corn syrup is thick, right? And that's our hypothesis, and that's why we think it. Alright, our materials. We're going to be using soy sauce, Coca-Cola, vanilla 0, Wesson vegetable oil, Caro dark corn syrup, apple cider vinegar, and Poland spring water. And so first we're going to measure our beaker. Our beaker weighs 94.4 milligrams. It weighs grams, 94.4 grams, and so that's how much that weighs, 94.4 grams. So now what we're going to do, we're going to start off with the Coke, and we're going to add 50 milliliters. Okay. So.
Okay.
Actually, we do, so here we're going to get 50. Oh, Nike.
50 is out of 5.
For a reason, idiot.
Alright. So we've got 50 right here, and now what we're going to do is we're going to put that 50 into this 50. To make it more scientific, and so we're going to pour that in there, all 50 of it. Make sure it's all in. We don't want any validity issues. Now what we're going to do, take this sucker out, and make sure you swish it around. And put it back, and now, don't touch that. Now what we're going to do is 50 milliliters of each. Weigh the filled beaker. Now we're going to weigh it. So this weighs 143.6. So, okay, so pretty much what we need to do. That way, alright, so Coke. 143.6 grams.